Project 2 is a continuation of the work done in the first project. In Project 1, I assembled and tested the Lynxmotion 3 Degrees of Freedom Robot Arm. After getting a sufficient understanding of how the robot moves, I was ready to implement more operation-relevant features. For Project 2, I aim to implement color detection, forward and inverse kinematics, and object detection for cubes. In the remaining time, I will discuss these features and briefly touch the goals for Project 3. I wanted to program color detection to gain the ability to provide an input color for a pick-and-place operation. For example, if shown the color red, the robot can place the given object on a red piece of paper. To do this, I used OpenCV in Python. I capture frames from my laptop's video camera, take a subregion of this image, and test the subregion for the presence of red, yellow, green, or blue. To prevent false positives, I set a detection threshold in which a given color must be detected for 150 consecutive frames, ensuring a non-anomalous detection. Upon reaching this threshold, the program can transmit the detected color. For testing, this is done via a console printout. For the actual robot, however, I will need to transmit this data to the robot's microcontroller. With the detection done, I transition to the robot's kinematics. I was able to calculate the forward and inverse kinematics for the robot using the work done by Dr. Rainer Hesmer. Though the Lynxmotion platform has a different link configuration, using Dr. Hesmer's work, I was able to model the Lynxbot as a 2R planar robot that sits on a rotating base. I implemented the derived equations using NumPy and tested the behavior with a variety of angles and expected positions. I'll have to fine-tune the link lengths and base height variables via trial and error, but the core functionality is present, which is a great success. For object detection, I began to use OpenCV to detect edges of a rectangle. After completing this, I contemplated using a deep learning framework like TensorFlow to detect cubes. Ultimately, however, I decided that object detection was unnecessary for its intended use. Rather than attempting to detect the pick-and-place object for each operation, I can simply keep track of its location using additional variables in my code, saving both computer resources and precious project time. As a result, I have decided to refrain from implementing this feature. With color detection and kinematics implemented, Project 2 is complete. Looking to Project 3, my main objective will be to synthesize the previous two projects, allowing interplay between the Python code and the Arduino-controlled robot. I will also need to construct the robot's operating environment and test the arm's behavior for optimal movement speeds and object placements. I look forward to any comments or advice you may have. Thank you for watching.